always has to come in and tell me push the red button. Just for the people at home who watch this later, I'm Dwayne. I work at Pantheon. That's me in front of another screen. People raise their hands, and I'm saying why we're doing this is all these reasons. And the slides are all available online, by the way. If you're all like, this is confusing, if you go to mcdwayne.com, which is my website, all the slides are there under the title of this talk. Let's learn Git, no excuses. All right. There's a minute by this guy, Linus Torvald. I don't want to say Linus because it's Linux. But Linus, in 2005, said there's got to be a better way for all the people building this thing called Linux to collaborate. They're central version control systems. The idea of a version control system isn't new, but they're all centralized. They're slow. They're server-spoke relationships or hub-spoke relationships. It's this really heavy weight, and then permissions, especially if the team gets really big and distributed. So they set up this method to do this. And my favorite quote from Linus Torvald, maybe of all time, is, "The smartest decision I ever made in my entire life was to put Junio in charge of the project." And he's been running it ever since. This is the guy who maintains the Git repo for Git. And he's hilarious. If you go read some of the older pull requests, the guy's great. It's wonderful lightheartedness to a very serious matter. And they designed it pretty quickly. They realized that, wow, this is a lot of applications outside of what we're doing with Linux, like a lot. And they wrote all the documentation to talk about the knowledge worker, which is a pretty wonderful way to describe people. Anyone that handles documents at all is a knowledge worker. Everyone in this room is a knowledge worker. I guarantee you have a phone with documents on it, you are a knowledge worker. The basic idea of Git is this. We're going to create a document, we're going to save a document, we're going to edit a document, we're going to save it again, and we're going to keep track of all the modifications for that document over time, be able to explain ourselves as we go along. This is the heart of what they wanted to do. Communicate as a team better and explain what they were thinking when they made a change and when they pushed that change somewhere. I keep using the word document, but really we're talking about projects here. If it was just a single doc, Git probably wouldn't exist. But has anyone ever actually looked at the source code for Linux? Yeah, it's big, it's sprawling, it's massive. There's a lot of files. Who's ever written their own module before? It's not one file. It can be, but it's not. That's what we're talking about. We're talking about whole projects at a time. Excuse me. This is it. If you completely comprehend what I'm talking about, by the end of this will actually make sense. If not, keep thinking Git's a weird time travel device, and it kind of makes more sense that we have forward in time, backwards in time, parallel realities we can jump between and re-merge those things. That's kind of it. A super important thing to remember with all this precursor knowledge of Git is that there's no such thing as a Git server. There's Git repositories on machines you don't own. That's GitHub and other places. But every version of Git, every time a Git instance happens, and we'll talk about what an instance means, it's somewhere else out in the universe. It might know that, but it thinks it's the only thing. It thinks it's local to itself always. This is a really important concept with it. This took me forever to wrap my head around, but once I did, the whole project made a lot more sense. Git is super lightweight. If you're SFTPing something, pushing it across with FTP protocols securely, you're moving the whole document every single time. So if you make 2 character changes in a 10 meg doc, you move 10 megs across to get that update. This is the problem with Windows updating. Git only moves deltas. So if you move 2 characters or change 2 characters in a 10 meg doc, the only thing you push across the wire is 2 characters, however fast that is. It's extremely fast. It's the fastest way to distribute code in the world. It's not a backup tool though. Don't pretend it is. Don't treat it like one. It's a wonderful way to go back in time and see what you did and keep track of your code. But we're talking about the CMS world here, and that's why we're at Drupal Camp. There's a database to deal with, a file system to deal with that you're not tracking. There's vendor directories and do or don't commit those. If you went to the composer talk yesterday, there's a lot of problems with that. Anyway, but don't worry. This is the best documented anything that's ever existed as far as I can tell. The documentation is amazing. If you're on a computer right now, just type in Git tutorial. There are pages after pages after pages of results. In fact, though that's how you're going to get the most out of the rest of this talk, is open up your laptops, pull them out, and just play along. As I said earlier, you can't teach a kid to ride a bike at a seminar. I can tell you how to do all this stuff, but unless you get this in your fingers, this will never make sense. You can think about Git day in and day out, but until you actually start applying it and it becomes second nature, like this is just how it works, you won't ever master it. So, how do you install Git? You go to git-csm.com. Any operating system in the world can deal with Git. Super lightweight, take you a few seconds to download. If you're pull my slides from mcdwayne.com, those are links that actually go out to those repos. I'm going to talk about the command line interface, because the command line interface gets rid of all of the magic black box of it, and it's just a command line interface. If you're not familiar or comfortable with your machine's command line interface, it's time to start. The command line is amazingly powerful and lets you do things with your machine that GUIs just simply don't let you do, and you have true power over what you can do. So all the talks that you could go to about automated testing and all of these wonderful frameworks and whatnot, they're relying on CLIs to be there and to work. So I'm going to talk about the CLIs, but don't worry if he's like, I really don't want to use a command line on my machine. There's amazing GUIs for this thing that you never have to see command line. But I think it's important to understand what's going on under the covers, and the CLI exposes all that. If I work with a magic black box, if it breaks, I have no idea where to even start thinking about how to fix it. If I know the underlying structures of what's going on, I can start poking around and maybe I'll find my own answers. And that's what I want to do today. So the rest of this talk is how to use Git and explaining the concepts through its use. And it's handy tutorial. So if you take my slides and do this at home, this actually works, all of this. So the first thing is this idea of git init. Not everybody uses this all the time. If you're starting a project completely from scratch, this is a mandatory process. All my slides work. I explain the concept and then I show an animated GIF. So you can play along at home later. So doing a git init creates this folder, an invisible folder called git.git is what represented in bash. And this folder looks like this. Just a regular old folder. Git's actually not doing anything that crazy, specific, or advanced outside of your file system. In fact, there's only one. Oh, come on in, man. Plenty of time. There's seats over here in the back, right there in the middle. Everybody. Make room. Make room. The best talk I went to about Git last year was at NedCamp, where he explained, I forget who did it, but explained exactly how Git works from like a file system level. And there's the hashing algorithm and deep inside of it. Other than that, it's just using the regular file system on your machine in a super intelligent way. It's not magic though, it's math. Anyway, after we created this file, what's in this file is keeping track of what you're doing. That thing called head keeps track of where you currently are. The hooks, the branches, the objects, that's all keeping track of various things. This is an intro, so we're not going to dig into this further than that. Just know that there's this Git folder, .git, and that's keeping track of everything for you. Super lightweight, and it just works. There's this wonderful command in Git called git status, that whenever you're lost, whenever you're like, I don't know what to do now, you can type git status, because it always works. And it's just a wonderful command, because it will tell you exactly what the state of the world is. Hey, I made an initial commit, but I have none of these things in red actually committed. Okay, well I know what to do now. If I'm working in my normal workflow, I know, well, those aren't committed anywhere. This is the core of 90% of what people do with Git right here in the screen. This is it. So let's imagine for a second that, let's see that table over there with the cups and the water on it. That's a state in time that is in that position. And I can say, that is my working directory. That represents what I'm doing on my machine. So if I open a file, I'm typing in it in Sublime Text or Text Wrangler or what have you, PHP Storm or have you, there's a state of the world like, all right, my hands are off the keyboard, I hit save, now my working directory is that. I can say, I want to take a snapshot of that exact table the way it is right now, and save that at this point in time, and that's called git add. So now Git says, all right, I'm paying attention to that way that table looks right now. Then I can say, all right, I want to actually commit this to my long-term memory. And I can write a message, like put that snapshot of the table into a file folder write on the outside of the file folder why I put it in there at that time, what's exactly in the contents, as verbose as I want to get, and then stick it in my file cabinet, and that's the repository. And at any point in time, I want to go back and look at those previous commits. That's possible. So using the table analogy, it's like this is the way it is right now. But if I go in and make that change and hit save, all right, now I can add that into here, and I'll commit it again and say, all right, move 2 stacks of cups, water more to the right for me. Now I've committed that one. I'll do it again. I'm not actually going to do it. But if I did, I can do this all day. Git add, git commit. Git add, git commit. You can do this in repetition forever. You can add individual files one at a time. So if I don't want to add the whole thing at once, I can do individual file names. Say, I just want to add my index here. And that's the only thing I'm going to track with Git. And Git's like, okay, I'm just going to pay attention to that file from here on out. And git add dot is the shortcut that I use constantly, and let's just say everything in my working directory that I can see. I'm going to just track it all now, and I'm going to say that has been added at its current point in time. Then when you write a commit message, you get to say, this is officially what I have done. Be verbose with this. There's no maximum to this. There's a short description, which is 55 characters long. After that, you can write into a file, however long you want to write a file. Your commit messages should be very, very verbose, because later in the future, you're going to thank yourself. You're writing yourself little notes in the future, and all of your friends and coworkers notes in the future about why you did what you did when you did it. So if you go back in 3 weeks, like, this bug came out of here, why did we do this? Oh, this is why I justified it. Whew, okay, we're good. We can go back and fix this now. Quick note, if you are doing this as a tutorial, if you forget the -m flag, which seems like weird to throw a -m flag this early in the operation of the thing, it's like, all right, we're going to write a commit message now and drop it in your default editor. And unless you specifically set it up otherwise, your default editor is Vim, or VI. The only 2 things I know for sure about VI are, one, it's the most searched for term on Stack Overflow is how do I quit VI? And 2, if you hit the letter I, escape, then type :WQ, it lets you type, and then :WQ is right quit. That's all I really know about VI. It's powerful. I do know a little bit more than that because I've had to learn it, but it's not my editor of choice. And then you can do this all day. You're going to modify it, add it, commit it. And what you end up with is a history. This is what your commit log is. This is why you're doing this. Your git log shows you exactly what you've done. If you do git log, it will say this very verbose, very stupid long number. That is the magic algorithm of Git. That's the only thing that's specific to Git inside of the Git protocols and file system, is this hashing algorithm, which is kind of really awesome. The chances of there being 2 hashes that are the same commit ID are like 3 billion to 1. There's only happened once, and that was in a controlled lab experiment where they specifically tried to make it happen. And they've succeeded, but it's never happened in the wild. It's a very safe way to store these changes over time and share them around the world, no matter how big the team is, no matter how big or unruly the project gets. One line is just a little flag you can throw to make it a little prettier. That's what I'm doing at the very bottom there. Show it real quick. Yeah, that's what I do. So when on my machine, if I do, that's way small. If I do my git log, git log --1 line is, oh, I'm not in the right folder. Hold on. Yeah, here is my actual public git log I do for my, yeah, forget the DH store one. I was really mad about DH store. But here's actually what I do with my actual content for my site. I version control my content. We'll get back to that idea later. But I can see exactly where my ideas came from, when I inserted what. This is way more useful in my private writing, like blogs and personal journaling, because I can go back and see at any point in time what I was thinking without having to go back and reread my work. I can just see git log, like, oh, that's where that came from. That's where I was. what's the name of that bar? Oh yeah, there it is. My Git logs are weird sometimes. And if you ever get to a point of like, well, what did I do in this file? What did I actually change? There's this cool tool called git diff. And that's what you're seeing. Diff doesn't know that you've added a single character in a line. It knows that you took a line out and added a line in. That's how it thinks about it. If you modify one character in a line, it's like that whole line went away and this whole new line appeared. It's actually really easy to skim through your diff file because of that. You get the minus is red and the pluses are plus and they're green. Everybody ever create a diff file before? Yep. A few of you probably don't need to be in here if you've done that already because this is an intro. But this is how we do the patching system. We'll create diff files and pass those around. And rather than pushing the whole project in pull request system like you've seen other places, if you want to submit a patch, you create a diff file and say, this is what I've changed. And from a diff file, which is a specific file Git will generate, other people can apply that to Git, and it will just push that change, one change in you made. Very slick way to do this. You can also do Git diff staged, which is a different thing. Shows you a different point in time, but that's not really for beginner class. Git diff is the thing you need to know. So far I've talked about going forward in time. And something I failed to say, because I don't think it's really important until we get to here, is Git is a graphical based system. If you go to git-csm.com, their official website, and look at any of the official docs, and scroll down to the very bottom of the doc, there is most likely, other than some config docs, a graph with nodes, with circles and lines that explains the concept of what you just read. So if you're on your machine, like if we look Git rebasing or Git cherry picking. Git cherry picking is a great one. It will actually cherry picking is probably my favorite example of these charts. The whole idea was around, we have these points of time that we have these. There's a one big timeline. We're going to call that a branch or a tree. We're going to call it a branch. And off of this branch, we're going to hang these moments in time. And these nodes of what we did, we'll hang a blob of what the actual information is. And up in the node above that blob, we will keep track of what we're doing. That's where the comments go and whatnot, and the metadata for it. So you can start thinking of like a timeline, like we learned in school. You have 0, 1, 2, 3. And we all learned in school that timelines don't just go one way. Those are called vectors, not a timeline. Timelines can also, or number lines can go back 3, 2, 1, 0, and negative. Git doesn't have the concept of negative really, but forward and backwards in integers it really does. So every time you make a new commit, you're putting a new blob on the chain, a new node on the chain, keeping it branching out. We can easily go back with this system. We can say, I want to go back and take away the thing I just did. It's called revert. This is an extremely safe way to deal with going back in time. Because you're saying, I'm going to go back one step. So if I'm at 3, you say revert 3, and now you're back to 2. And it's like 3 didn't happen, except it knows it happened. It keeps track of it happened. And if you need to revert your revert, it will let you do it. So like, okay, I took that away, and now everything's back to broken. I guess that was the right fix. And then we have this other bug to squash. All right, we'll revert our revert. Sounds a little silly, but this is a very easy way to like step backwards in time to get to a point where you didn't break it, and then go back forward. And still, Git's actually going to keep track of the other changes you tried. Those, if you do reverts, the previous commits don't go away. They're still there. You can go back and look at them. We'll talk about that when I talk about branching. So if you want to go back and learn what you did and why you did it wrong, or it will stay in your history, you can go back and look at it at some point in the future. You can also go back and reset things hard. This is dangerous. Don't do this unless someone on your project specifically tells you to do this, or it's your project and you can make that kind of authority call. Git reset hard is super useful if you're working by yourself and you made like 30 Git commits and they were all wrong, and you realized, oh, it was this other change I needed to make. I'm going to make sure none of this ever appears in my history and I never have to deal with it ever again. Git reset hard will just make it all magically go away. Oop. There we go. That's what it looks like in practice. But what you end up with is a long Git tree, Git reset, and then Git one line. It's like change 4, the 4th change, and that revert never happened. That's it for forward and backwards, though. That's all you really need to remember. Git add, git commit, git revert. Now you've done 95% of what you use Git for. I'm not kidding. Anybody in the room use Git on a day-to-day basis that came in here for laughs? Is that far from the truth? Like, we run into other situations, but 90% of the time we're doing like forward or a couple steps back. That's what I found in my work. There's a lot of other use cases for it, and this is where Git goes from a cool tool to keep track of time to one of the most powerful development tools that ever existed. Git has this really simple idea of Git branches and merges. Because we are storing these points in time on a tree, we can easily say, let's branch that out. And now we have 2 parallel lines that are reality. One's called origin. That's our master branch. That's the default name for the first branch. You got to call it something, so Git, by default, calls it master. You can call it whatever you want. And then you can name the other branches whatever you darn well please to keep track of a new feature you're working on. So if you're working on something that's like, I would like to experiment and do something radically different with this piece of code. Oh, I'm going to create a new Git branch and go do it over there. Because the things I do in my branch will never affect my master branch until I merge them back in. I have the control to say, all right, only when it's shippable, only when it's ready, now I'm going to merge that thing in. So to make a new branch, you just say git branch and name the new branch, and one magically appears. So if you just say git branch, it will just show you the list of branches you have. Like right now on this one, I only had master. Say git branch, new branch, for lack of a better name. Do git branch again, and there it is. New branch. Now to use that branch I created, all I'm going to do is check it out. Checkout means something radically different than it meant in central CBSs, where you have a master client relationship. So has anybody ever used SVN? Okay, so the idea of checkout in SVN is like you control that repo now, and you are the only person that can edit it. That is not what this means in Git, so you're going to have to forget that part. It threw me off when I was first learning it too. Git checkout means we're looking at what we think reality is in our working directory right now is whatever Git thinks it is. And let's go back to that reality. So we can check out a different branch and be in that reality now, or we can check out anything that has a Git ID in that tree, which means we can go look at literally anything else in our Git log and say, what was the current reality when this Git log ID happened? Oh, there it is. You can just git checkout, put the ID in there, and you're good to go. Git checkout branch name is more common usage because now we're going to switch over to that other branch and we're working in that reality. Again, not reflected in master until you're ready to push it in. So here, I'm making a change in a doc that now I'm working over in the my Git branch. And there's my Git status. I have this thing here. I've added it in. I'm commenting on it. Add a new line and a branch. And Git status. Great. Git log, one line, and there it is. That's that commit I just made. Add a new line and a branch. And then if I go over to master, thing with animated GIFs. Now I'm on master. I'm going to go look at my Git log there. And, oh, that ID doesn't exist down here because that reality is not the same as my branch reality. I know I'm kind of overstating this, but this is super magical. One of the more impressive things about Git, because you can now freely experiment. And I'm not going to mess up anybody's work. I'm not even going to mess up my own work. And if I think, oh man, this was a really good decision, I need to get this code into my main code, all I got to do is merge it. Because how you merge it is you say, hey, merge into me. And this is where everything being local actually kicks back in. Git always thinks whatever reality is in is the real reality, and it's in charge. So I can merge things in by saying, hey, pull this into where I am now. So in my master branch, I'm going to git merge with my branch to merge with. It's going to suck those changes into where I live. You can do it the other way, but this is the common way. Git merge, tell it where to pull things into. There is a downside to git merge, and this is merge conflicts. This is the sad trombone of the Git world. This is where a lot of people throw their hands in the air like, oh, why is this so bad? Detached heads are terrifying and scary when you first encounter them, but they're not actually that bad. Once you figure out how to deal with detached heads, which everybody will hit, I guarantee you if you're actually trying this stuff, that's not scary. Merge conflict can be, depending on how complicated the merge conflict got. And basically, you're at a point where Git doesn't know who's supposed to win. You've modified the same file in the same place in two different places, and Git's not sure who's actually in charge. Which one actually should have won in the Git log, in the Git history. When I put these merge Git logs in order together and make it one big Git log in master, which is the right one? And it will say, I don't know. So it will do this, where it will say, well, here's what the head says. That's where I was pointing at when I started. And here's where new branch says it should be. I'm not sure. You tell me. Super easy to fix. You just go in and actually fix it. And now you're at a point where Git's like, oh, this is the new reality. I can deal with that. Great. Git add, git commit. It all works great now. I'm happy with that. I'm really happy now. Because you have to make that decision of like what's true reality. So you have two developers who are working on a project, and one's working on a plugin over here, or a module over here, and the other person's working on a theme over here. Probably should never have a merge conflict when you merge their work together, because those code pieces should never touch. If you have two developers working on the same theme, the same twig file, who wins? The Git doesn't know, and half the time the development team doesn't either. But Git has some tools to kind of help with this. That will make your life a little easier. If you don't set them up and you just type git merge tool, Git says, hey, I don't have a tool set up. Here's the ones I suggest. There's a ton out there, and this is where I normally open up SourceTree. SourceTree is a GUI that is pretty powerful, and it's got its own little logic layer of figuring out Git conflicts. But that's the only reason I ever open up SourceTree. So what about this thing of remote repositories? We've talked about the basic ideas of git add, git commit, going back in time, parallel universing. What about the ones you don't know? So GitLab, GitHub, Bitbucket, at their core, GitLab has another task runner system that we're not going to get into today, but all of these support the Git protocol because it's Git repositories on machines you don't personally own. That's all it is. It's cloud computing for your Git repository. So if you don't have a GitHub account, get one. You really should have a GitHub account by now. It's one of those namespace grabs you should really have done at this point in your life, like Facebook, Twitter, Instagram, and GitHub, among others. But this is what the interface looks like. It's slicker. There's no command line. It drops you into automatically. It's way more user accessible. And this is where the idea of like pull requests come from, which we're going to get to in a minute. This is where it's super important to remember that everything's local. I know I've said that several times now, but this is the one where like if you can grasp this, everything else is easy. Every one of these repos thinks it's the only repo. It knows the other ones exist because you said specifically, explicitly to that Git repo, there's a remote repo over here that's a clone of you. It's like, okay, I can keep track if that clone's identical to me or if that clone's varied from me. Okay, but it still thinks it's the one in charge, and it always will. You're the one that has to tell it which one's in charge and which one's right. You're in charge of it. Git's dumb in that regard. It doesn't know who's supposed to win. There's no server. There's no central hub spoke. There's just remote servers. Or, I'm sorry, just remote Git instances. Could be on your machine, your friend's machine, a server, GitHub, and it doesn't matter where it is. You're going to name that repository that's not the local one something else. Origin is the most common name. It's the one by default that it comes up with. So there's the string we'll get to in a bit where you see the word origin, like that's just the name of that remote. So if you build a new repository and you go on GitHub, you can set it up and it will give you all these steps to add a remote repository. And you won't ever have to type all of this. You can just copy what it gives you. But it's saying, hey, git remote, add this origin of this destination online. And now I know that there's this repo somewhere else on a machine that's not my machine, that's a clone of me that I think should always be in sync with me. Let's speed up just a little bit here. So we can push things to this origin. And we say, all right, true up, and I am the right one, accept my accept my push, and now you're going to be in sync with me. And if you own the repository, if you have all the rights to it, if you're working locally and you're working against another repo you own, this just works. So this is how I push up changes to my repo all the time. It's how, in fact, I can do it real quick right now. Let's see, change. Let's see what my Git status is here. Okay, git add, git add, git. These shortcuts. Demo. That's a really bad commit message, but I just wanted to show this. So I'm going to say git push. I'm going to push where? I'm going to push to origin. And which one am I going to push? I'm going to push my master branch. And if it all works right, it's going to say, all right, I packaged up all the deltas, and we moved all of 11 kilobytes of information across the internet. That was it. Now, if I go to my GitHub repo for this, it will be in sync. I know exactly what it will be. In fact, if I run git status again, one of the things it'll actually tell me is my branch is up to date with origin master, and there's nothing to commit. Clean working tree. I'm good. I'm good to go. The opposite's true as well. If there's a repo that, hey, this changed over here, and now I need to true up my local, git pull. I'm going to pull these changes in, and that's the new reality. You'll run into some convolution with this when you start talking about updating entire upstreams at once, if you're doing major updates to things. But don't worry about it. For most of the time, git pull just works. Or it will tell you the specific error message of, hey, you need to add this bit of information to it because I don't know exactly what you meant. So we can push, we can pull. This was done for a workshop, so it was demoing it back and forth. But honestly, the reality of making repo or remotes is somebody already did it for you, and that's why they're on GitHub in the first place. So if you ever go to a repo, there's a thing called git clone. Git clone says, hey, establish a GitHub or a Git repo, make it the repository, link it to the repository online automatically, and then do a pull of everything down. It does a bunch of steps at once, but it significantly links the code on your machine to the code online. So you can git push, git pull, and it should just work if you own everything. If you don't own everything, that's where we need to have a conversation. Enter the pull request. Who's ever made a pull request in their life? Awesome, that's way more than I thought it would be. So what you've done is you've created a new branch and said, hey, I think these changes need to be applied. All a pull request is a branch, a discussion, and a merge. That's it. That's all the fancier it gets. It's just the idea of branching and merging, but we need to have a conversation in between because somebody is in charge of that repository online, and they have the authority to say yay or nay. I'm taking it or I'm not taking it. Sometimes multiple people do in groups. Different programs allow for different setups and organizations and whatnot. But this is it. Any of those people on the right for you, they could say, hey, I have this idea. And the person on the left would be like, no, that's not a good idea. Explain it better. And if they explain it good enough and he says, well, that's the way it should work, then in this particular case, he'll pull it in. Okay.
So just think about this from a management standpoint. So I don't want Green Sweater to be a jerk, in essence.
You know what?
I don't want Green Sweater to be a jerk.
Oh, no, you don't want anybody to be a jerk.
But like, they have the power.
They have the person who owns the repo has the power. So like I wrote a tool called Post It Now for how I post my my blog for WordPress. If you said, hey, here's this idea for it, and I say, that's a terrible idea, or I just never answer you, yeah, that's not a great way to be. Ideally, I'd be like, hey, this is great input, I have some questions. And that's the way git log or git pull requests should be reading. Is like, hey, I don't understand what you're doing here. I have questions about it. And that's like the ideal situation. But then we're back to human beings. And Git's a wonderful protocol, but it can't fix humans.
Yeah. It
can fix version control. That's about it. So this is what I memorized. This is everything in my head about Git. This isn't 100% true, but this is most of it. Everything else in the entire universe, I use DuckDuckGo. Specifically, I use DuckDuckGo for code because they built this awesome feature in recently that does what you see on the right there that will just show you the doc. It's like, oh, you ask about this? Here's the doc I can find. There's a Git rebase doc. That's directly from their documentation. Here's the stash doc. uncommitting. Uncommitting is not a command, so it doesn't know how to read that, but it'll link to various pieces. But it does a better job than Google, specifically for the development world, I think. There's all sorts of fun websites, and again, thousands of tutorials online. I'm not joking about this. I read about 20 of them as I was building this for the first time and watched maybe 100 videos. Super well documented, and these cheat sheets are absolutely great. This is the one I started with. So whenever I got stuck, I would just, that looks terrible on the screen. You download it, make it really big. It's a PDF, and it's everything we just talked about in one thing you can print out and leave by your machine as you're learning all this stuff. But don't be scared of it. Like, honestly, you can unstick yourself from any situation. Oh, I went the wrong way. Sorry. From any situation in Git. So again, I'm Dwayne, I work at Pantheon, and this is what I memorized. About to go forward in time, back in time, parallel universe, and collaborate with others with Git. And open up for questions. Sure.
So is it true then you don't have permission of the remote repository? You do a pull request. Your admin, whoever's there, pulls the code. Could you do a git push? No, it's just going to overwrite the repo.
No.
Can you repeat the question for the recording?
Absolutely. Thank you. If you don't own the repo and you submitted a pull request and they say no, we don't like that pull request, can you do a git push and force it over? The answer is no.
So the git push would just fail.
The push would fail. In fact, if we go back to the screen where I show this. At the very bottom, notice how it says commit directly to the master branch, and there's another one that says create new branch and commit. This is because I own this repo. If I didn't own the repo, that first line wouldn't exist. That commit directly to the master branch. I think it's completely removed. Actually, I haven't done that in a while. But anyway, the option's not there for you. You can only do pull requests on repos you don't own.
Makes sense.
Yeah.
Silly question.
That's not silly.
Can I make, so I want to use Git at my workplace at least to keep track of my stuff.
Okay.
Can I just have like a local instance of Git? Because we
Yes.
have this whole tinfoil thing about.
The question was, can I have just my own private local instance of Git? And the answer is yes, very loudly. Git's always only local. Everything's local with Git, everything. There's no exception to this. So yes, the answer is yes, a resounding yes. If you want to store all of your stuff in Git, every document you've ever written, please do it. I firmly believe we should start teaching Bash and Git to kindergartners as soon as they learn how to read. That sounds crazy, but I think Git will replace the library system. This technology was invented in 2005, and 80% of developers in the world use it right now. Name another technology invented in 2005 besides Facebook that we all use.
HTML.
Twitter, like the big social media platforms, but like the core technology to it. Like HTML5 doesn't even have that kind of adoption yet. And it's like pretty darn good. It's a better way to understand how we understand information, I think. Other questions? All right, repos and everything are online over at mcdwayne.com, which is my website. Look for this talk. What do I call this talk? Let's Learn Git, No Excuses. There's talks, and there's even a video of me giving this talk somewhere else already up there, and an example GitHub repo you can link to if you go through the workshop slides. But have fun with it and use it. If you don't use it, you'll never learn it. Pick like your own writing or something and just start using it, and you'll be surprised how useful it is.